Okay, the meeting is being recorded. I wanted to announce something. Next Monday, we will not meet like this. You will still do the class exercise and lab. The reason is that I am having a 4-day meeting for an organization called ABET. If you don't know about it, ABET is Accreditation Board for Engineering and Technology. It is the premier certifying organization for certifying engineering programs, computer science programs all over the world. So I'll be visiting virtually an institution to certify its computer science program. I'm one of the commissioners of ABET. So you can see here, it is a certified organization that accredits college and university programs in applied and natural science, computing, engineering, and engineering technology. So there is something called Computing and Accreditation Commission of ABET. So I'm a commissioner there. So every year I lead a team to visit an institution in the United States or overseas and evaluate their computing programs. It could be computer science, information technology, and so on. So I will be attending a meeting, a number of meetings actually, starting next Sunday, Monday, then it goes on to Tuesday, and then it ends Wednesday afternoon. So Monday morning, I have a lot of meetings with the college, the university president, and people like that. So I will not be available most of Sunday, Monday, Tuesday, and Wednesday. I will not be available for any meetings, any office hours. I will have no office hours. I'll be probably not also grading anything because it's meetings from morning till evening. Normally, we would have done a face-to-face visit. We would have really gone to the institution and then spend some time, spend 3 days there, but that is not in the cards this year because of COVID issues. So in a nutshell, no scheduled meeting next Monday, but I will make the lab and class exercise available to you. I will make reasonable deadlines so that you can complete them. I will make them available pretty soon and make them maybe due next Monday evening or something. Okay. You can still work your class exercise in a group and do the lab independently. All right. So that is the first thing. Any questions? And week after that, we have the second exam. So I'll be posting some information about the exam as well by next class. Any questions? Okay. Then one thing I did not talk about while posting the lecture slides or video is regarding this new topic, loops, and how it fits in the overall realm of things. So let me go ahead and talk a little bit about things we have done and how loop fits into the scheme of programming. So this will probably take about 10-15 minutes. Okay, so in the first 4 weeks of this course, we saw some pseudocoding. We saw assignment statements. We saw arithmetic, how to add, subtract, etc. in Python. We also saw some turtle graphics. Then, of course, week 5 was the exam, and 6 and 7, we saw selection statements. If, elif, else, nesting them, etc. And this is week 8, 9, and 10. Of course, 10 is exam. 11, we'll see loops. What is a loop? As you have seen in the video and in the lecture slides and from the textbook, a loop means we have a sequence of statements and we are repeating that. We repeat that until some condition is satisfied, or repeat that a certain number of times. That is called a loop. Now, so we saw all these things, then we saw selections. Now we are going to see, or we are seeing loops. So these are 3 different types of so-called control structures. How to control your execution. So sequencing is the first one. That is, you write a sequence of statements like A equals B, C equals D, and A equals B plus C plus D, these kinds of things, one after the other. So this is a sequence of statements, and the sequence gets executed in the order these statements appear. So that is the first thing that we learned while programming. That is usually what people learn when you start programming. A sequence of statements that are physically together, one statement placed after the other, and the sequence of execution is exactly the physical order. So this is one control structure, statement after statement. The next control structure, how to control the program, is through selections. We wrote, if this is the condition, then we have, we are going to do something. If something else is true, we'll do something else, etc., etc. And now we are seeing loops. So these are the major control structures in computer programs. What is significant about this set is that any program that you can write to solve a problem can be written using these 3. That is, if there is a problem that can be solved on a computer by writing a program, then that program can be written using these 3 types of statements, using a sequence of statements, using selections, and using loops. And in general, you need all 3. So this is both necessary and sufficient to write, to solve any computable problem. Computable problem meaning problems that can be solved using a computer. Not all problems can be solved using a computer, right? There are lots of problems that we face. For example, I have to rake leaves. I don't think I can write a program to do that. That kind of stuff. Or if I have to mow the lawn, I have to do it myself, right? So these are the types of programming control structures we need to solve problems. So we have learned this, we have learned this, and now we are learning this. So with this, you would have learned all control structures we need to solve computable problems. You will learn lots of other things, but these are the most fundamental things we need. Okay. That is the first thing that I wanted to say. Do you have any questions about anything regarding loops or anything that we have done? Any questions before we proceed? Okay, then I assume you have no questions. Let me show you some important aspects about give me a second. Let me share the screen, the PowerPoint. I wanted to show you a couple of things before we started the class exercise. Where did it go? I'm trying to find the window for, okay, here. Okay, yeah, so we are doing loops and obviously we are doing while loops. You write while and put a condition and put colon and then put a bunch of statements here, okay. So one thing I wanted to show you here is that in this case, we are adding up a bunch of numbers. Actually, in this case, numbers 1 through 1000. And when you want to add up a bunch of numbers, you have to have a place where you store those, store that sum. And of course, this is not quite, I'm sorry, that is not quite what I was, this is the program where we are adding up numbers. So we are having the total stored in a variable called total, and we are adding to total a number, right? This is called an accumulator. An accumulator accumulates values. It adds up values. It keeps a total in that. So this is the variable that stores the total of a bunch of numbers. And this is called an accumulator. The typical code for creating an accumulator, using an accumulator, is to initialize it to 0. When you want to add up a bunch of numbers, you must have the initial total 0. That is always the case, right? And when you want to add a new value to this total, you write code like this: total equals total plus current, where current is the value that you want to add. So total gets incremented by this value. And notice the structure here. You get a value into current initially, and within the loop, you are getting the next value of current. You must try to memorize this structure. In fact, try to commit this program to heart so that you can remember this pattern. This is so used so frequently, you will benefit from it. Doing something before we enter the loop and repeating it once in the loop. Setting an accumulator to 0, adding a value to it. You will use this kind of structure in different contexts so many times that you shouldn't be looking for that pattern. You should, and wondering what to do when you get into such a situation. So it is worth understanding this piece of code thoroughly and try to see if you can capture that image in your mind. It is going to be so useful. Look at the two things that are colored here in maroon or something. Current equals int input, enter a number. That is repeated right here, because that makes it easy to program. So you are getting a value into current, using it, and then getting the next value, and then using it, and then getting the next value. You are sitting here in a loop, getting the next value and using it. But before using something, you have to have an initial value. That is why we have it outside of the loop initially. And see how this total is set to 0 and incremented here. Now, this is called the loop header while, and you put a condition that is called the loop header. Never forget the colon. Just like if statements have a colon, you should have a colon after the condition in the while loop. So the syntax of the while loop is very simple. It is just like if, except if is replaced by while. That's it, no difference. And you can have statements indented. They are all considered for execution while iterating the loop. So you have those terms: iterate, iterations, loop header, this is the loop body, etc. And when you have a loop like this, while number less than 25, make sure that that number is set to a value before you enter the loop header. Otherwise, you will have a crash. The other thing is, if you are having a variable, or you have a condition in a while loop, right? At least one of those variables should be given a new value. Otherwise, you are likely to have an infinite loop. And that often is not what you want. Okay? Any questions? Anybody? Before we take attendance and then go to the class exercise and eventually the labs. Anybody? Okay, then I'm going to take attendance. Abdifata Abdullahi?
Yes.
Thanks. Umar Farooq Bashir? Umar Farooq Bashir? Ian Bentley? Ian Bentley? Adam Boru? Adam Boru? Luis Duran Enriquez?
Here.
Thank you. Adam Felling?
Here.
Javier Frias?
Here.
Leticia Hendrickson? Leticia Hendrickson?
Here.
Okay, thank you. Nikki Cubes?
Yep.
Thanks. Jordan Lee?
Here.
Thanks. Abdi Mohammed? Abdi Mohammed? Alexis Morales?
Here.
Sivhong Nien?
I'm here.
Thank you. Hunlachu Sebgaze? Unlechu Sebgaze, Parker Talley.
Here.
Thanks.
Thank you.
Linda Wang. Linda Wang.
Here.
Thanks. Santiago Villanueva Montoya.
Here.
Thanks. Samuel Boson.
Here.
Thanks. Thomas Waterman.
Here.
Thanks. Taylor Williamson.
Here.
Thanks. Satavin.
Here.
Thanks. Chu Yang.
Here.
Thanks. It appears one or two might not have responded when I called the attendance, but I will see what I can do about that later. Okay, let me go ahead and create the breakout rooms.